Hello all, I am Masud Rabbani. I am the co-author of this paper, which is accepted in AI Pervasive in 2021. The paper title is MPredA, a machine learning based prediction system to evaluate the autism level improvement. And here is the author list with the affiliation. Here is the outline of this paper, which I am described one by one. First one is the background. So autism spectrum disorder is first identified in 1943 by Kerner as a children's behavior, and then later is identified as a neurodevelopmental disorder, and which is known as autism spectrum disorder or ASD. Now it is a global problem, and people of all society levels are suffers from this from ASD. About 1 to 5% of children have been suffering from ASD in developed countries. For example, in USA, out of 54 of 1 children has suffered by ASD. And in the developing country like Bangladesh, is not the number is not exactly known by us. So in the global, about 46% of children do not get proper treatment after the identification of the symptom of ASD. So it is a global problem. The main contribution of this paper is to update and develop update their parents and develop their demography. If they learn earlier the improvement level of the children based on their current demography, and which demography is most important by the development of the children. And in this study, we can predict 16 milestone parameters level in 4 major category, that is the daily living skill, communications, major motor skill, socialization. And based on our previous MCare project, we select most 10 important demography, which we based on this demography information, we build the machine learning models, and then we based on the machine learning models, we build the web application for predicted the milestone parameters improvement level. So here are some reference that are recent works related to this study. Like in 2021, there is a project developed where the demographic information is important before the development of the children of ASD, which is referenced by 20 here. And in some other developmental children level of ASD is developing by video analysis in Bangladesh is also referenced by 2. And we also evaluate the DDM status of children with ASD based on their machine learning model, which is referenced by 21. Here is the methodology, that is the flowchart of this study, where we select the dataset from the MCare, then the pre-processing the dataset by mean value or filter methods. After that, we train and create the machine learning model. Here we also use 4 type of machine learning model, that is decision tree, linear regression, KNN and ANN. After the validation the model, we selected 4 importance pickles for the development of web application. Here we use R-square, ROC and AOC for the validation of model. And we also use the Django for development the web application. After the development of web application, we use white box testing for validation the web application. So here is the data set for project, where we use the MCare project. Our previous MCare project was funded by NIH, and protocol with the with the referrals of the IRB information, we collect the behavioral and milestone parameter for 150 patients from Bangladesh for 1 year. Here is some data of this 4 center that we collected the patient from Bangladesh. The first 2 center, NIMH and IFNA, we got 100 patients, and AWF and NISPAP we got 25 and 25 patients. So based on the demography, we have collected the behavioral parameter from this 150 patient. Here is some demographic information. We collect the demographic like age, their gender, their education, the parents' education level, and their occupation also. So in our previous work, we proved the most 10 importance demography which is important for the behavioral development of the children of ASD. In data processing, we have 2 steps here: the data cleaning and the feature extraction and the binarization. We have observed in data cleaning, we have observed that some noisy data in our data set, which we had no impact on machine learning model. We removed this noisy data after we found some missing specific data like the age and the family expenditure column. We clean this data using the filter. We developed the more popular method, that is the attribute mean value, to handle this missing data. For the feature extraction and the binarization, this is a very critical step in building our dataset to develop in the machine learning algorithm. Initially, our datasets had some non-numerical value columns, that is out of 19 there is 13 columns with more than 1 features in our 1 column. For example, in father education, 3 had no educational labels information of mother in 1 column. In this step, we did the feature extraction and binarization process simultaneously and convert the set on 45 according to the table of demographic information. The columns with only numerical values, 0 for negative and 1 for positive value. Besides this, we also applied min-max scalar to convert all these features in the range of 0 to 1, and this conversion is very important to increase the machine learning algorithm performance. As we also know that the data processing process is very important to build a robust and significant machine learning model. So here we use 2 kind of data processing step. One is data cleaning and other is data feature extraction and the binarization, which we use in our future plan. And the feature selection is important for any machine learning model, created machine learning model, where we use 4 types of feature selection method. Here we screenshot 2 importance machine feature selection model, that is universal selection and the feature selection important approaches. Based on these 2 approaches, we select most 10 importance demography which is important for the development of the children of ASD improvement. After that feature selection, here we got 10 most important features, that is the family expenditure, father age, mother age, father occupations as a businessman, mother as a homemaker or housewife, children's education in the specialist school, mother's education level, their living space, and their number of siblings in a family. So these are the most 10 important factors or demographic information that are used to predict the development of the ASD children in Bangladesh. So we also assure our data set and by coefficient value between two columns, and we got r equal to 0.01 score, which is very good for the data quality in the data set. After selection the best 10 importance demographic information, we build the machine learning model using 4 different machine learning algorithms: the decision tree, logistic regression, k-nearest neighbor, and artificial intelligence. And also we use 2 different methods for validation these machine learning methods. There are R-square value and ROC and EAUC values. So here is some screenshot of our machine learning model score with the validation score. Based on this validation score, we select the most important and most significant machine learning model to create the pickle for our web application. For the web application, we select the model and pickles for the our 16th data set or data problems. Our 64 models, we select this 16 most important and significant machine learning models to create the pickles, and this pickles has been deployed to build the web application to predict system to evaluate the autism spectrum improvement, that is our MPredA. In the web application, we have used this base 16 pickles files, developing the web application to predict the milestone parameters improvement based on the children's demography. This pickles has been run on the Amazon web server to predict the 16 milestone parameters. The website front end was designed implemented by Django, and also the dataset was in the SQLite 3. After developing the web application, we have tested the application by white box testing. Our expert user and psychologist test the web applications in testing phase for 16 milestone parameters. Initially, we randomly select 18 inputs for 5 parameter each and separate them for white box testing purposes, and we got 97.5% accuracy among these 16 milestone parameters. So our whole project was developed in Apple M1 chip processor with 8-core CPU, and for machine learning approaches, we use 4 different algorithms, machine learning algorithms, and for web application we use Django, Amazon web server, and SQLite 3 for the database. The experiment result we here use the demographic 10 demographic information with the 16 baseline parameter of the children, so that we can use this information to predict the milestone parameter improvement in the children. So here is the screenshot of our experiment result. We can see that here 4 different milestone parameters category with their baseline, so that the caregiver can input their current baseline data in their input field, and also in figure 4.A we insert the demographic information or the current stage. Based on these 2 categories of information, that is the baseline information and the demographic information, our system will predict the baseline, the milestone parameters improvement throughout the machine learning model we have trained based on our MK data. So by this data, the caregiver and care practitioner can know at the starting time of this treatment how the improvement level will be occur based on this demographic and the baseline data of ASD children. So the discussion is the mHealth research based web application can be used by both primary caregiver and also the care practitioner. They can use this application at the starting of the treatment process to know the development level based on the children's demography, and this web application can be used both in the home and clinical settings to determine the children's milestone parameter improvement level. The main advantages of this application is determining the improvement level of children with ASD milestone parameter without any clinical intervention. It can be done at the starting point of the treatment process, and the parents can know their children's improvement level based on the demography as early, and they can also update and change the demography to develop their children's milestone parameter. In this study, we have worked 16 milestone parameters in 4 categories, which was very common in children with ASD, and this data set is another size is another challenging issue in our work, as a real data set in this area is very rare to collect. But in this study we have tried to give more focus on the data integrity and data quality to get the more accurate result to determine the milestone parameter improvement in the development of ASD children. So in conclusion, we can say that in case of predict the milestone parameter improvement level, MPredA will be the first web application based tool on children's of ASD demography. We have used 4 robust machine learning algorithms with real patient data to build these prediction models in this system. The models used for developing MPredA application is most common and competitive, as we select 16 models among the 64 models. Among the 4 machine learning classifier, we have observed a decision tree as a effective and accurate classifier for this kind of data, as we have an excellent accuracy of all models and the web application. For example, here 97.5% accuracy with whiteboard texting. The machine learning based application will be a mental health development tool for the children with ASD. Through this type of this real set of data is very rare. We have the challenge to build up these machine learning models with this limited data set. It is expected that we will deploy this system with the same data set to build the recommendation system for the development of the children of ASD. So our project is partially supported by NIH granted grant, and the authors are also thankful for specialist Autism Healthcare Center, an institution in Bangladesh. They are the IPNA, NIMH, AWF, and NISPAP. And also we also thankful to the Marquette University for the IRB acceptance to collect the data set from Bangladesh. So here is some reference. So if you have any question, please feel free to email us or any media to contact us.